So far, we have seen the concepts of image and preimage, and those are also very useful into our understanding of how to set up a function. So let's use those now in the following example. Consider the function, let's call it g, and g maps elements from R into R, and those elements that live in R, let's call them x, which are mapped into g of x, which is by definition x squared. The image of the domain is given by g of R, and it is a subset of the codomain. So this thing here is the range of our function g. And by the way, it's given by all the positive numbers, including 0. Let's now ask, what is the preimage of the range? So g minus 1 of R 0 plus, what is the preimage? It's all those x's, all those elements x that are mapped into the positive reals or 0. But you see, that's the entire real line, so it is the domain. Okay, so in conclusion, the image of the domain is the range, and the preimage of the range is the domain of our function. We can now go even further with these two concepts. You see, because R here is the maximum domain that this procedure G supports, we could just choose some subset of R. So let's define now another function. Let's call it H. And H, instead of mapping all reals into reals, just maps from 0 to 1 to reals, okay? So each element x is mapped into h of x, again by x squared. What is in this case the image of 0 and 1? Well, it's the range of the function. So h of 0, 1 is by definition, well, all the elements from 0 to 1 as well, okay? Because when you square any number between 0 and 1, you get all those elements between 0 and 1 again, okay? So let's see this graphically. If you draw the graph here, our function is a parabola, like this. So this is x squared, this is x. So if you specify all those elements between 0 and 1, then the image here of 1 is 1. And so this thing here, all these elements x, which consists of the domain, are mapped into these elements here, again between 0 and 1. On the vertical axis that you see here. From this perspective, for each procedure, well, you can choose many domains as long as they are subsets of the maximum domain that procedure supports. And for each domain that you specify, well, as a result, you can compute the image of those domains and get the range, okay? But you see, for that given procedure, you can also think the other way around. Instead of, for the procedure specifying some domain, let's instead, from that procedure, specify some range. Consider then the function f, and instead of specifying the domain, let's specify instead what is the range, and let it be for all those numbers from 0 to 1. Okay? All those elements here, now let's call it x, and they are mapped into what? Well, f of x, and let f of x be, again, x squared. If you fix the range of this function, then that function can only act on those x's that are mapped into that range. As a consequence, the domain of our function f is the preimage of our range from 0 to 1. And so, in conclusion, for a given procedure, we have the largest set of inputs and also a largest set of outputs. So for a given procedure, now you can specify any subset of the largest set of inputs, and as a result that determines the image, a range, which is a subset of the largest set of outputs. So this is one way of specifying the function. You give the procedure and you specify the domain. On the other hand, you can also think as you specify the procedure, you choose some subset of the largest set of outputs. That is, you specify the range of that function. And now, as a consequence, now you have a very concrete domain, which is the pre-image of that set you just specify. Either way of thinking allows us to specify a function that we can work with. Okay? That's it.